For the sampling distribution of the sample proportion, we know the sample proportion p hat equals x over n. N is the sample size from the population. X is the number of individuals in the sample. So, for a simple random sample of size n with a population proportion p, there is a constraint. N times p times 1 minus p has to be greater than or equal 10. And the mean of the sampling distribution of p hat, mu p hat, is p. The standard deviation of the sampling distribution of p hat is square root of p times 1 minus p over n. Now let's do some problems. For the first question, we get this 0.35 is a population proportion, and the sample size is 100. The sample proportion p hat is 0.4. Based on the formulas, we know mu p hat is p, so it is 0.35. Based on the formula, I could get the sigma p hat. Then ask you for the probability greater than 0.4, so we know is the right side area. So Excel should be 1 minus norm distribution and 0.4, and the mean is 0.35 sigma, and always choose true. We see this answer and close this, the first one. So you choose a close one, best or close one. Now let's do the second question. So the sample size is 153 and the 45% is a proportion of population. And we know mu p hat is p. And this is sigma p hat. And we know this middle is mu, the mean, and here is minus 1 sigma minus 2 sigma plus 1 sigma plus 2 sigma. So we have lower bound is bottom, upper bound is here. So now let's do the mean plus 2 standard deviation. So mean plus 2 times, okay. And the lower bound is mean minus 2 times sigma. So we input, this is mu, and this is upper bound, this is a lower bound. Okay, number 3 is 106 is the sample size, 35% is population proportion. And we know mu p hat is p, and we get the sigma for the p hat. Same as the last question. Here is mean, and mean minus 2 sigma, mean plus 2 sigma. So the upper bound is mean plus 2 times sigma. Lower bound is mean minus 2 times sigma. Okay, we input the answer. So you need to round to 2 decimal places. Upper bound, lower bound, and the mean. Number 4, sample size 216, and the proportion of population is 0.35, and this is a sigma. So the mean is 0.35, sigma is 0.032. Number 5, we know here is sample size 104 and 33% is population proportion here. What's the probability that sample proportion is less than 0.27? So sample proportion is 0.27, and we have the mu p hat is a p and the sigma. So now is norm distribution p hat, mu p hat, sigma p hat, and true. Okay, so we input the answer. Number 6, Here 69 is sample size, 34% is p, and 0.3. This is p hat, and based on the greater than, so 1 minus norm distribution, and p hat, mu p hat, sigma p hat, and true. Okay, so we get this answer. Number 7, n is 142. This is p. The sample proportion p hat between 0.32 and 0.5. So this is between case. Goes norm distribution, upper bound 0.5, and the mean is 0.26, and the standard deviation and 2 minus norm distribution, lower bound is 0.32, then mean is 0.26, sigma and 2. We get this answer. We input. Number 8, 191 is the sample size, and 0.28 is the population proportion, and p hat between 0.36 and 0.48. So this is sigma, and we know that's also the between case. Say your between case. So the left area to this upper bound minus the left area to the lower bound. Norm distribution up bound, and the mean, and the standard deviation, 2 minus norm distribution and the lower bound. This is the answer. Now let's do number 9. Based on the question, 175 is N and 60% is P proportion of population. So the sample proportion P hat is X over N. So here X is 161 divided by the sample size 175. Okay, so the first question, is the sample size large enough? We base on the N times P times 1 minus P. Because we have the constraint, we check this greater than 10. So the first one is yes. Second question, mu p hat is just 0.6. And the sigma is, p hat is 161 divided by 175 is 0.92. What's the probability? At least 61. So that means the p hat is 0.92. So greater than this 0.92 equals 1 minus norm distribution and 0.92 and 0.6 and sigma p hat and 2. So we get all the answer.